talk about today is compounding at different time intervals. Okay? So in other words, we can make an investment somewhere. We could be cited an annual percentage rate, an APR. So maybe the annual APR of a particular place, is something like, let's say 3%, okay, which would be nice. A standard bank account, at least now at this point in time. Back in the 80s, like I mentioned to you yesterday, used to be like 7 or 8% in a regular bank account. You just deposited money. It's pretty good. Okay, and what can happen is you can compound at different times, okay, or I should say with different frequencies per year. That's what I really should say. So we can compound with different frequencies per year. The base formula that we learned about yesterday, the sort of simple formula, is annual compounding. So if you're going to compound annually, your balance as a function of time is always your starting balance. So when you see this notation B sub 0 or B naught, right, that means that it's the initial balance multiplied by 1 plus the rate, or the APR, to the T. Okay, and I'm saying annual. We're just going to let T be in years for all of these questions. So just make a note of that. T is going to be number of years. Okay, so you can do things a little bit differently. What you can do is you can go to some places and they'll say, all right, we compound more frequently than once a year. In other words, they don't wait till the end of the year to give you a piece of interest. They give you a small piece of interest each month. Okay, that would be called monthly compounding. Okay, and what do? Well, they say, all right, you're going to start with your initial balance, you drop it off, and at the end of the first month, instead of giving you R%, like they would at the end of the first year, they give you 1/12 of that. So they take the rate and they divide it by 12. They say at the end of the first month, we're going to give you 1/12 of the APR added to your balance. Okay, so now here's where things you have to be a little bit careful. Suppose you decided to put T up here as your exponent. You could say, all right, so T is my exponent. T is the number of years. There's a small problem. And that is, if we just think about this from a multiplying point of view, suppose I plugged in T equals 1 for the time being. If I plugged in T equals 1, that means I'd be taking B0, my initial balance, and multiplying it by 1 plus 1/12 of the rate only one time. And that's not going to happen if I have monthly compounding. As a matter of fact, if I have monthly compounding, I should expect to receive that interest 12 times during the course of the year. So we modify the formula slightly. Okay, what we do is the exponent now is going to be 12 times T, 12 times the number of years. Because for every time T goes up by 1, we should expect 12 more compounding periods. Okay? So now I think it would be sort of fun to compare two investments. So let's take the example we talked about yesterday. Let's start with $100. I'll talk about why we're going to start with $100. So that's going to be B0. Okay, and then I cited earlier in this little video here, a 3% APR. So the question is, does it make a difference? Am I going to do better, right, over the course of a year or a few years if I just get compounded interest once at the end of the year versus I get 12 little pieces of interest 12 times? Okay, so let's talk about that. So let's consider the annual case. So annually, we'll invest for 1 year. So B of 1 is going to be $100, which is my initial investment, times 1 plus my rate, which is 0.03, to the first power. So that turns out to be 1.03 to the first. 1.03 times 100 is $103. So I picked 100 as my base amount, or my B0, because now you can clearly see that my investment increased by 3%. So after 1 year, my investment increased by 3% if I'm compounding annually. So before I answer this, you should think to yourself, do you expect monthly compounding to do the same thing? I mean, I'm taking each month, I'm giving you 1/12 of that 3%, right? So maybe it should work out the same. Or maybe not. So B of 1 in the monthly case would be $100 times 1 plus 0.03 over 12 to the 12t. Okay? So, if we just take a minute to type that in our calculators, we get this in, we get, we'll have to round a little bit here, but it looks like $103.04. So, what we have here is an increase by 3.04%. This number here, while it doesn't match the APR, is sometimes referred to as the effective rate. And maybe you've gone into banks, you'll see things and they'll say, oh, there's a CD you can take out. Deposit $100 or $1,000 into our CD, and you get 2% interest for the year, and the effective rate on that interest is like 2.05%. So the effective rate is because when you compound more frequently, you actually get a little bit more interest than you would have if you just compounded annually. And it sort of makes sense. If you think about this formula for a minute, at the end of the first month, they give you 1/12 of the interest, 0.03 divided by 12. But then during the second month, you earn interest on the original $100 you invested, plus the little piece of interest they gave you for the end of the first month. So that's what's happening when you're compounding more frequently. You're actually earning interest on interest throughout the year. All right. So, a fair question might be, can you compound more frequently than monthly? And sure, for mathematics, we should be able to do mathematics. What if we can convince someone to compound maybe weekly? So, what does that formula look like? It looks like this. If you had weekly compounding, you would expect B0 times 1 plus the rate over 52 to the 52t. Okay? You can compound daily even. Every day they give you a little piece of interest. 1 plus rate over 365 to the 365t. So sort of a fun question is, hey, how much better do I do if I go to a bank, I drop off $100, and then they give me interest at the end of that day? Right at the end of the day, they say, thanks for leaving that money with us for one day. Here's a little bit of interest. Tomorrow you'll get a little bit of interest on the $100 plus the interest you earned from the day before. So the question might be, how much better do we do if we go from, say, monthly to weekly or monthly to daily? So let's type those things in. So this would look like B of 1. We're going to talk about 1 year for now. It's going to be $100 times 1 plus 0.03 over 52 to the 52 times 1. And then also B of 1 down here would be 100 times 1 plus 0.03 over 365 to the 365 times 1. You should take note of these exponents. Take a look at this exponent here. It shouldn't surprise you. If you're compounding weekly, in 1 year, you would expect to receive interest 52 times. So that's why we're doing 52 times 1. If we were going to invest this money for 2 years, you'd have 52 times 2, or 104 compoundings you would receive. You'd receive interest that many times. So sometimes, rather than just memorizing the formula and thinking, oh, well, if it's monthly, it's going to be 50, weekly, it's going to be 52t, monthly is 12t, daily is 365t, you should really think of this exponent as the number of times we receive interest. Don't forget I before E except after C. Okay? Let's figure out what these two numbers are. So for this one, we get $103 and 4 cents. And I'll just put some extra decimals here so we can see what happened. Let's go to 365, and we get $103, and it rounds up to 5 cents. So it's sort of interesting to compare all these numbers, right? So let's sort of summarize what happened. So I'm going to call this number of compoundings, okay? And we're going to compare that to the investment value after 1 year. And while we're at it, we'll also write the effective rate. Okay. So, in the case of annual compounding, we're receiving interest one time a year. So 1 goes here. The value of the investment at 3% interest was $103. And the effective rate, my money went from $100 to $103. I increased by 3%. Okay. The second case, we decided to compound monthly. And we saw that we got $103 and 4 cents. It's rounded right around there. And the effective rate now is 3.04%. So it's 4 cents. It's not that big of a difference on $100, right? Make it more money than that, and all of a sudden the decimal starts to move over, and you start to get enough extra money to buy lunch or something. Okay. Yeah. What happens when we went to 52? When we went to 52, we end up with this number, $103 and 4 cents, and I'm showing you these extra decimals here just so you realize it almost rounded up. Okay? It doesn't round up on $100 investment, but if we were to double it, it might. What do you end up with? You end up with 3.0445% effective rate. So something interesting to compare is, why don't you look at the difference in growth between these 2 years versus, or not 2 years, 2 compounding strategies versus those two compounding strategies. And what do you notice? It's not as big a jump to go from monthly to weekly as it was to go from annually to monthly. Right? And watch, we go one more, we go to 365 days of compounding, we get 103.0533, or we get an effective rate of 3.053%. And if you compare the difference here, we have an even smaller jump than before. Okay, so we're not seeing big growth. So sometimes people will say, what if we compound even more frequently, right? So what if we compounded twice a day, right? 730 compoundings. Let's see what happens. Get an investment value of $103 and 045. These, I think I made a mistake up here. I need to check. This number's off. I made some mistake there. I'll fix it in a minute. This is 4. So I've got an effective growth rate that's really no different from that one once you round. It ends up being the same. What should that number have been? So forgive me, I wrote that incorrectly. That was 0453. So this number would have been 04045. And then this number is so just barely bigger than either one of these. So what are you noticing? You're noticing that as the number of compoundings, right? So we'll say as this number here heads towards infinity, if we start compounding all the time, this number heads somewhere special. Okay? I think at this point we could probably convince ourselves it's never going to make this. It'll never make it to 4% or 7%. Right? It's not growing fast enough for that to happen. So there's some limiting value over here. There's some limiting value. Okay? And that's what we want to start to talk about next. So in a future video, we will talk about what that limiting value is.